Vermont in the 1950s. It was a place of rural roots and stunning landscapes, of independent, strong-willed people. A place where agriculture remained, as it had for years, the most visible of the state's industries. But change was afoot. In 1954, two economic blows hit the Burlington area. The combination, the closing of the woolen mills in Winooski and cutbacks at the GE plant in Burlington, brought unemployment in the county to nearly 12%.
In 1956, the Greater Burlington Industrial Corporation was looking for an industry to lease a small building it had constructed on a cow pasture in Essex Junction. In January of 1957, the International Business Machines Corporation announced it would lease the building to manufacture a piece of electrical hardware called the wire contact relay.
In Poughkeepsie in 1957, we were building the wire contact relay in building 52. And there just wasn't enough room. So they said, we've got to have more room to expand and develop this product. And so the buzzword came out as, hey, they're going to Burlington, Vermont. 26 of us flew up in a DC-3, and we got rental cars and went to the Hotel Vermont. The next morning we got up, we were told we were going to come out here to open up the site. And thank goodness we came at 7:30 because it was one of those typical February Vermont days, cold, windy, had 100 people in line. And we went to the back line, in front of the line, so on, found out someone were there at 4:30 in the morning.
Just about 3 months after the plant opened, I was hired, and, well, like any new plant, they were a little hectic. We had a lot of equipment to put in, and a lot of new people, but we got to know each other.
By the end of the year, the plant, known as IBM Burlington, had more than 400 employees and was manufacturing relays by the millions. As the plant geared up operations in the 1950s, it provided the technology for IBM's first all-transistor computer. It used magnetic core memory and standard module systems cards from Burlington. These cards contained all the discrete circuit elements needed to build the system.
Hello, I'm Walter Cronkite, bringing you highlights of IBM's progress during 1959. It has been a year of colorful and exciting events, some of them of great significance for the future. For example, the introduction of jet passenger travel and the IBM solution to the complicated problem of airline reservations in the jet age.
The 1960s marked a period of tremendous growth for IBM Burlington, finding itself at the core of IBM's rapid expansion and leadership in the computer industry. The electromechanical nature of Burlington's production was about to be transformed by an earlier IBM edict that all future product development would use solid-state electronics. The announcement in April 1964 of IBM's System 360 changed the face of computing technology, the IBM company, and IBM Burlington.
In 1963, as you probably know, we had the mission to make SLT product here, and it seems like from that time till now, the plant has just sort of exploded.
A new technology with virtually no significant distance between components. Microelectronics, in which 50,000 transistors overflow a thimble. The basic elements of solid logic technology, chips and substrates, meet to form a circuit. As many as 6 of the active elements are placed precisely on a single circuit.
Surging demand for System 360 propelled Burlington into the first of several major expansions. First came construction of a 300,000 square foot facility we know as Building 963. The site was adding nearly 40 people a week to its payroll. By 1966, Burlington had nearly 3,000 employees.
We had to expand quicker in some places, and we actually occupied the Beverage Mart on Park Street. We had purchasing and production control located in there. Management development was located in where Domino's Pizza is today. We set up test equipment over at the A&P store.
Interestingly enough, industrial engineering was located at the Duval House up on Maple Street here in Essex Junction, right where the softball fields are.
They rented space at 40th and Allen, had a lot of module activities there. They rented space where the current Essex post office is, and on Pearl Street, and that's where test equipment was.
During the mid-60s, IBM engineers developed methods for integrating multiple devices, such as transistors, resistors, and capacitors, on a single silicon chip, creating the integrated circuit, or IC.
And it just so happened that in 1966, IBM was going to ship its high-end scientific computer, Mod 95 System 360, to the National Security Agency in Washington. And that machine had a special System Protect memory on it, small. And Eric says, I want you guys to build that thing out of integrated circuits. Now get out of here. And then we all looked at each other and said, none of us had worked in integrated circuits. He had to pick out a circuit for the IC memory. It was called the Farber-Schlag. It was 6 transistors for 1 bit. 6, and it was bipolar, and it worked like a charm. Absolutely. Now that was a disruptive technology, because before that there was core memories, and this was going to take cores and just bare them.
This was followed 2 years later with a Burlington-developed 64-bit memory chip, again used in several IBM System 360 models. As the decade ends, the site has 4,000 employees, and the construction of 3 new buildings are completed or underway to house development and administration employees. Advances in chip technology in the 1970s brought dramatic improvements in computing speed and storage. After producing 64 and 128-bit bipolar memories, Burlington tried its hand at IBM's new field effect transistor process called MOSFET. Although bipolar products would remain faster for many years, MOSFET offered distinct advantages in power consumption, ease of manufacture, and scaling.
There are 2 chips on the top surface and 2 chips on the bottom surface, making 4,000 bits on the module. These modules, which are Burlington product, are put in these systems. And here's
Shalom Lewin works in the product assurance area, which is responsible for guaranteeing the reliability of our memory devices.
Right here is the memory.
The initial 1,000-bit Riesling chip quickly led to 2K and 4K memory chips. IBM's System 370 was now using Burlington chips for its main memory. In fact, chips had now replaced all memory and logic functions in IBM's large systems. By the mid-70s, Burlington had become known as the memory capital of the IBM Corporation.
What impact does this rapid escalation in integration level have in the memory marketplace? Well, 1 megabyte of memory would have rented for $37,000 a month just 5 years ago. Today, a megabyte rents for as little as $5,200 a month.
We will be checking them underneath this light for foreign material.
One of the things that we learned was that the Kodak carousel projector with a very strong light made an excellent tool to see contamination, and we went out and bought all the ones we could at Gaines.
During the 1970s, Burlington engineers were making progress on developing a technology called silicon and aluminum metal oxide semiconductor, or SAMOS, incorporating the IBM-invented one-transistor memory cell. This technology would hold the key to putting IBM years ahead of the competition. That lead materialized in 1978 when IBM took the electronics industry by surprise, announcing a memory chip capable of storing more than 64,000 bits. The 64K chip, and Building 970's new Alpha line with its SAMOS technology using 3.5-inch wafers, put IBM Burlington on the world technology map. By decade end, the site had grown to almost 2 million square feet and 7,000 people.
The hiring at that point in time was just phenomenal, and what was happening is that we were preparing for the next spurt of growth. Right after I arrived in 1979, we had Building 973 was just started to be built, and in close succession after that, we had 975 that was being built. We had the new cafeteria that was being built, and so all of a sudden, that lobby that we originally arrived in and walked up to the stairs when we entered into IBM was hidden by all these other buildings that were built around it.
In 1981, a new 3-story state-of-the-art chip fabrication facility opens to produce chips on 5-inch wafers, an industry first. At the same time, the new building employed a new process, using silicon instead of metal, to form each transistor gate.
We've invested more than $100 million in constructing and outfitting this building. The result is a novel 3-layer structure with approximately 150,000 square feet of space on each of its floors.
IBM purchased more than 400 acres in Williston in 1982 and begins construction of 3 buildings to house design and development operations. Construction plans include a 658-foot bridge across the Winooski River. It remains the only IBM-built and owned bridge. For the first time, employees pledge over $1 million through its charitable contributions campaign, a record that employees would meet and surpass several times in the years since. Throughout the 1980s, IBM Burlington's progress in memory chip technology is rapid and noteworthy. Then, in 1984, Burlington attracted worldwide attention for fabricating a memory chip capable of storing more than 1 million bits of information on its existing manufacturing line. In 1987, Burlington engineers describe a chip with 4 times more capacity and sub-micron features. This new 4 megabit chip is Burlington's first memory to use a new technology called complementary metal oxide semiconductor, or CMOS.
One of the consequences of scaling is as you make devices smaller, they get faster. And it turns out that MOSFETs scale better than bipolars do. You can scale to smaller voltages with MOSFET. What happened was then, over the years, as MOSFETs got faster and faster, and then CMOS came along and reduced the amount of power that the circuits required, eventually they got to the point in the early 1990s where they were better than bipolars.
The production line gets yet another facelift in 1988 as the site announces that it is the first chipmaker producing on 8-inch silicon wafers. The larger wafers increase the number of chips that can be manufactured, improving productivity and reducing cost. While memory was the site's claim to fame, it also begins to rapidly develop its expertise in logic chips and microprocessors in the 1980s. That includes application-specific integrated circuit, or ASIC, logic chips that in 1988 have up to 40,000 circuits in the IBM AS400 line of computers. 1986 also brought the IBM RT PC, the first product to use a 32-bit microprocessor. The Burlington-made microprocessor is based on an IBM-invented architecture called Reduced Instruction Set Computer, or RISC. Burlington closed the decade as one of the largest producers of semiconductor components in the world, with a site population of approximately 7,000.
The thing I'm most proud of is the great strides that our manufacturing personnel took. Not many places can say that their manufacturing people have stepped up to the bar like they did in Burlington.
In the 1990s, IBM Burlington continued to achieve new memory chip milestones, but the product menu shifts towards microprocessors, as well as logic chips for multimedia, telecommunications, and other special purpose applications.
And there was a realization that as the density of components increased and so on, IBM could not consume all of the capacity that we had. And so to make the division viable, we were going to try and sell on the outside. And the first thing that we sold was memory. And there was a fascinating story about that. Of course, none of the primary companies would buy from us because they didn't know who IBM was. They didn't know whether we were really in it to stay. They didn't know the quality of our products. And so we were going out, and the first sale was made to some third-tier company on the West Coast. And I remember when Mike Kincannon's guys came back with the first check, which was for $1 million, it was a big check, the controller here in Burlington didn't know what to do with the check. He put it in his drawer at night because we didn't have an account into which to put product revenues.
By the late 90s, Burlington is designing and manufacturing the industry's most complex application-specific integrated circuits, leaping from number 5 to number 2 in worldwide ASIC sales.
When we talk to the external ASIC customers now and ask, what do you like best about IBM? The answer almost always is the people. And I think that's a reflection on not only how we put together the design system, but the relationship that we have between the developers of the library, the developers of the methodology, the technology developers, and of course, above all, our manufacturing and supply chain teams.
In 1997, IBM was the first in the industry to make chips with copper wiring.
I mean, it was a transition that we absolutely had to make from aluminum to copper, especially with the microprocessors that were so fast. They demanded a very low resistance back end of the line.
I think everyone else was waiting to see what IBM would do. And so we stepped out there, did it first, and since then everyone has followed. All the major fabs use copper for wiring.
IBM Burlington has created products, technologies, a whole industry that has changed how we work, live, and play. Few could have imagined that a single building in an open field with 400 employees and a simple relay product, could grow and prosper to become a worldwide high-technology leader.
I don't think we had any idea how far it could come.
Yeah, I had a great time.
IBM has some of the most wonderful people.
No place else in the world was doing it like we were doing it.
We just wanted to be successful, and we willed it, and we were.
And who knows what we're going to be making. It's been a long road, and there's a long road left to go.